Hi guys, let us look at the work done in an elastic material. The work done in an elastic material is equal to the average force times extension produced by the force. The average force simply means half of the force that is applied, and so we can write that the work done is equals to half F, which is the force, times E, which is the extension. This is an important formula used in calculating the work done in an elastic material. But we can recall from Hooke's law that the force is equals to the elastic constant K times the extension. So if we put this Ke into this equation, we can rewrite the formula for work done as half Ke times E, where Ke represents the force and E represents this extension, so that the work done becomes half Ke squared, where E squared is E times E. So this is another important formula used in calculating the work done in an elastic material. So we can use this formula or this formula to calculate the work done depending on the parameters given. Now, this work done is also the same thing as the energy possessed by the material, because for work to be done, that material must have energy. So we use the same formula to calculate for the energy of the elastic material as well, not just the work done. And the unit of work done and energy is given as joules. So let's look at an example. A stone of mass 20 gram is released from a catapult whose rubber has stretched through 4 centimeters. If the force constant of the rubber is 200 Newton per meter, calculate the velocity with which the stone leaves the catapult. So in this instance, the catapult possesses an energy because catapult is made of a rubber, so it possesses elastic potential energy. And like I said before, energy and work done has the same formula. So based on the parameters given, we are going to calculate for the elastic potential energy of the catapult that is later converted into kinetic energy of the stone. So let's sort out the parameters. The mass of the stone is 20 gram. We can convert it to kilogram by dividing 20 by 1000 to give us 0.02 kilogram. The extension produced when the rubber is stretched, the rubber of the catapult, is 4 centimeter. By dividing it with 100 by 100, you get 0.04 meters. And the elastic constant is equals to 200 Newton per meter. So we are looking for the velocity with which the stone leaves the catapult. Like I mentioned before, the elastic potential energy of the catapult will be converted into kinetic energy. So the elastic potential energy will be equal to the kinetic energy with which the stone moves or leaves the catapult. The potential energy will be equal to one of these formulas, and looking at the parameters, the one that have K is this one. So we rewrite it as half Ke squared to represent the potential energy equal to half mv squared is the formula for kinetic energy. We are looking for V, the velocity. So we are solving for V by making it subject to the formula. Since this is equal to this half can cancel out this half, and we'll be left with Ke squared equals to mv squared. So let's solve further. Ke squared equals to mv squared. Let's put the values into this equation, and that gives us K is 200 times E is 0.04 square equals to M is 0.02 times V square. This will give us 0.32. If you put this value in the calculator, equals to 0.2 V square. To obtain V square, we divide both sides by 0.02, so that 0.02 V square divided by 0.02 will give us V square equals to 0.32 divided by 0.02 gives us 16. To obtain V, this square will cross the equation sign to form a square root, so that V is equal to the square root of 16. And the square root of 16 is 4. So the velocity of the stone is 4 meters per second. And this is the answer. Please try this. A spring is compressed by 0.02 meters. Calculate the energy stored in the spring if the force constant is 400 Newton per meter. Please put your answer in the comment section. And thank you very much for watching.